fx equals to 2x minus tan inverse of x minus ln x plus root over of x square plus 1. We have to show here that function steadily increases as x increases. That means we have to show that it is a strictly increasing function. When x increases, fx also increases steadily. That means we have to show it is a strictly increasing function. Now, we take this one as gx minus hx minus some px, where gx equal to 2x, hx equal to tan inverse of x, and px equals to ln x plus under root of x square plus 1. This is a linear function, that is gx is a linear function, linear polynomial function. Nomial function. So differentiable. Hx equal to tan inverse of x is also a differentiable function. Is also a differentiable function. Px being a logarithmic function, px equals to x square plus 1. So being a logarithmic function, px is differentiable. As fx equals to gx minus hx minus px. So fx is differentiable. For all a's greater than 0. For all a's greater than 0. Now we differentiate. It is 2 minus 1 by 1 plus x minus 1 by x plus root over of x square plus 1 into 1 plus x by root over of x square plus 1. Now this gives us 2 minus 1 by 1 plus x square minus 1 by root under of 1 plus x square. Now we simplify these two first. So what we get? 2 minus 1 plus x square 1 plus under root of x square plus 1. Now we take LCM once again. 2 plus 2x square minus 1 minus root over of x square plus 1. This gives us 1 plus 2x square minus root over of x square plus 1 by 1 plus x square. For all x greater than 0, 2x square greater than x square. Now this implies 1 plus 2x square is greater than x square plus 1. X square plus 1 is greater than root over of x square plus 1. This implies 1 plus 2x square minus under root of x square plus 1 greater than 0. And this implies 1 plus 2x square minus root over of x square plus 1 by 1 plus x square greater than 0. This implies f dash x greater than 0 for x greater than 0. That f x is strictly increasing. Is strictly increasing for all a's greater than 0. So from this we can conclude that this implies fx steadily increases as x increases from 0 to positive infinity. Now fx is continuous at x equal to 0. So this implies fx is strictly increasing for all a's belongs to 0, infinity. And this implies fx greater than f of 0. So 2x minus tan inverse of x minus ln x plus root over of x square plus 1 greater than f of 0. F of 0 means when we put here 0, so the ultimately the whole result will be 0. And from this what we get 2x greater than tan inverse of x plus ln x plus under root of x square plus 1. Y equal to ax cube plus 3x cube plus 2a plus 1 into x plus 1000. We have shown it is a strictly decreasing function for all real values of x. And for that we have to find the, here we don't have to show that it's strictly decreasing. It is the function is given and we have to find the value of a for which the function is strictly decreasing. We have to find the value of a, parameter a, for which the function is strictly decreasing. So we consider this one as fx. Now being a cubic polynomial, fx is a differentiable function. Fx is a differentiable function. So f dash x equal to 3ax squared plus 6x plus 2a plus 1. Now we have assumed this to be a cubic polynomial. So a should not be 0. That is the first point here. Since fx is a cubic polynomial. Is a cubic polynomial. So a not equal to 0. Now we need the whole expression to be less than 0, as we want the whole function to be strictly decreasing for all real value of x. So this quadratic function should be below x-axis. Now for this quadratic function to be below x-axis, a should be less than 0. For 3ax squared plus 6x plus 2a plus 1 less than 0 for all x belongs to R, a less than 0, and discriminant of the quadratic should be less than 0, which implies 6 whole square minus 4 into 3a into 2a plus 1 less than 0. We take 12 common, so 3 minus 2a square minus a less than 0. We write it as 2a square plus a minus 3. We write 2a square plus a minus a greater than 0. Now we factorize 2a square plus 3a minus 2a minus 3 greater than 0. This implies 2a plus 3 into a minus 1 greater than 0. Now we take a number line, minus infinity plus infinity, minus 3 by 2 and 1, plus power odd sign changes, power odd sign changes. So since here a less than 0, we can take only this interval. That is, we can say here, for all a belongs to minus infinity comma minus 3 by 2, 3ax square plus 6x plus 2a plus 1 less than 0. That is f dash x less than 0 for all x belongs to R. Therefore, fx is strictly decreasing for all x belongs to R. Therefore, required value of a is in minus infinity comma minus 3 by 2. That is a less than minus 3 by 2. It is given a function f of theta, which is 2 sine theta plus cos theta divided by 3 sine theta plus 4 cos theta. But to show that for all theta belongs to R, the function is increasing. Let f of theta equal to 2 sine theta plus cos theta by 3 sine theta plus 4 cos theta. Define for all R minus n pi plus alpha. N belongs to 0, where alpha equal to tan inverse of minus 4 by 3. Now, in this given domain, the function is differentiable. F of theta is differential. Is differential for all r minus n pi plus alpha. N belongs to Z, where alpha equal to tan inverse of minus 4/3. Now f dash theta equal to 3 sin theta plus 4 cos theta whole square u by v, so v square. Now v into digit of u, so 2 cos theta minus sin theta minus 2 sin theta plus cos theta into 3 cos theta minus 4 sin theta. Now we simplify. We get 6 sin theta cos theta. This into this. Now 3 sin theta minus sin theta minus 3 sin square theta plus 8 cos square theta minus 4 sin theta cos theta minus 2 sin theta into 3 cos theta minus 6 sin theta cos theta minus 6 sin theta cos theta minus 2 sin theta into minus 4 sin theta minus 8 sin square theta minus into minus plus. So plus 8 sin square theta. Cos theta into 3 cos theta, 3 cos square theta minus. So minus 3 cos square theta. 4 sin theta cos theta. Whole divided by 3 sin theta plus 4 cos theta whole square. Now, if we simplify here, what we get? 6 sin theta cos theta, 6 sin theta cos theta. Now, these two got cancelled out. We are left with 5 sin square theta plus 5 cos square theta. That if we add up, it is 5 only, because cos square theta plus sin square theta is 1. Now, 3 sin theta plus 4 cos theta whole square. That is greater than 0. For all theta belongs to r minus n pi plus alpha, n belongs to z, where alpha equal to tan inverse of minus 4/3. F dash theta greater than 0. So f dash theta greater than 0 means f theta is strictly increasing for all theta belongs to this interval. So after this we write, this implies f of theta is increasing in its domain. In its domain.